right, thank you, Jay. Focus of my talk today is going to be on early detection and monitoring of aquatic invasive species in Lake Michigan. But before I really dove into the specifics of the work going on in Lake Michigan, I wanted to make it clear that this is part of really a larger effort in the Great Lakes for early detection and monitoring, and similar efforts are going on in all of the Great Lakes. And so with that, I thought I'd start this talk talking about a little bit more generalities regarding the Great Lakes themselves. The Great Lakes, as most of us are aware, of course, the largest freshwater system in the world, contains about 21% of the world's freshwater, 84% of North America's freshwater. Provides, as we know, a variety of unique wetland and nearshore and deep water habitats that support a wide diversity of plant and animal and fish species. This wide biological diversity contributes heavily to the region's economy. The economic value of the region is estimated to be about $15 billion annually. $7.1 billion is related to the commercial and sport fisheries alone. It supports 85,000 jobs, 58,000 specifically related to the sport fishing industry. Non-native species, there's a total that exceed 184 species for the region. On average, one new species is introduced every year. Not every introduction results in a successful establishment, and not all will cause negative or ecological impacts. AIS threaten native species through competition, ecosystem processes and health, through nutrient cycling and energy transfer, as we've heard in some talks today, and as well as the economy. The economic loss for all AIS in the Great Lakes is estimated to be greater than $5.6 billion, with $4.5 billion loss in commercial and sport fisheries alone. Because of these risks and impact to the region, there's been several initiatives recently to help combat aquatic invasive species. The Great Lakes Restoration Initiative in 2010 outlined a strategy to tackle this issue through determination of invasive hotspots, develop early detection and sampling plans, and monitoring for fishes and macroinvertebrates, essentially to find rare AIS before they become common. And by 2014, develop a basin-wide surveillance program with shared sampling protocols and methodologies to provide early detection of non-native species. In addition to the Great Lakes Restoration Initiative, there's the 2012 amendments to the Great Lakes Water Quality Agreement between the U.S. and Canada, which essentially says that within 2 years to develop an early detection and rapid response initiative. There are several pathways or vectors of invasion, which include maritime commerce, such as ballast water and hull fouling. In Lake Michigan, about 48% of aquatic invasive species come from this vector. Hydraulic connections, like canals, locks, water diversions, and rivers, 10% are known to have entered Lake Michigan through that vector. Organisms in trade, such as aquaculture, aquarium pets, bait, release of live food fish, 20% of the AIS are known to have entered Lake Michigan through that vector. And there's other vectors as well, including water recreation, diving, fishing, agency activities such as habitat restoration, rescue, harbor maintenance, and illegal activities such as unauthorized introductions. Well, based on these vectors or pathways, we use some proxies of those, such as numbers of ships from international and national airports, national ports, hydrologic connections, and human population size to conduct a risk analysis for Lake Michigan. And what you'll notice is most of the invasion hotspots using those proxies are located in the southern part of Lake Michigan, which include Calumet Harbor, Chicago Harbor, Burns Harbor, and then in addition to those areas, the Port of Milwaukee and the Port of Green Bay. So using that, we developed a surveillance plan for AIS in Lake Michigan, as well as in other areas as well, following similar hotspot analysis. We used various tools, one of them specifically for Asian carp, using environmental DNA. Sample sites are prioritized based on likelihood of Asian carp becoming established, spawning there. And where we actually collect those water samples are in areas of accumulation such as backwaters and eddies. And then run DNA analysis on those. The only concern about using this as a standalone method for Asian carp surveillance is the vectors can include, of course, mucus and eggs from Asian carp, but they also can pick up other vectors, such as DNA coming off of birds and bird feces and boats, side of boats if they're not cleaned appropriately. So just in case, if there's evidence of a positive eDNA mark anywhere, it doesn't mean that the fish are necessarily there, but yet eDNA could be through these other vectors. And so there's a more comprehensive effort to include not only environmental DNA, but also ichthyoplankton. For fish larvae and zooplankton, we use light traps and bongo net tows for that. Some traditional gears, for juvenile and adult fish, we use electrofishing, experimental gill nets, paired fyke nets, and minnow traps. We're also monitoring macroinvertebrates using sediment grab samplers and colonization plates and rock bags. For the ichthyoplankton and macroinvertebrates, we go through those and identify them manually in a lot of cases, but we're also looking into using next-gen sequencing to help with identification, especially of those less common species. The eDNA sample locations that we've been conducting since 2013 have been on the eastern and western shore of Lake Michigan, ranging from Sturgeon Bay, Fox River, Sheboygan area, Milwaukee River, and also over in Michigan, Muskegon River, Grand River, Kalamazoo River, Paw Paw River, St. Joe River. And the areas in which we're sampling are those areas determined to be, again, most likely where Asian carp are most likely to become established if they do enter Lake Michigan. And for all the results are posted on a website that I've got listed here. And as you can see from this table, the amount of effort that we've devoted to taking eDNA samples has increased since 2013. In some of our targeted areas, as we've learned more and more about Asian carp as a whole, in areas that they're more likely to become established, we've directed more effort in some locations and less in others. But overall, our effort to detect Asian carp using eDNA has increased since 2013. Out of these, over almost 5,000 samples that we've collected, there's only been 2 samples that have been collected with positive eDNA results. The rest of them have been all negative. We had 1 positive in the Fox River in 2014 and 1 positive in the Kalamazoo River in 2014. But subsequent resampling of those areas since then, in 2014 and 2015, have all come up negative. And so that suggests to us that the DNA that was collected in those rivers were probably from other vectors other than fish being present in those systems. For our traditional gear and our ichthyoplankton surveys and our benthic surveys, most of our effort has focused around the hotspots that I outlined earlier. However, in 2015, we did have the opportunity to do some additional sampling at CSMI sites, focused around Manitowoc, Sturgeon Bay, Racine, Waukegan, Arcadia, Ludington, Saugatuck, and Benton Harbor. But most of it, again, focused around the hotspots that I identified earlier. And what you notice from this table is a list of all the sites that we have sampled for AIS using traditional gears and benthic and larval fish techniques. And as you can see, from 2013 to 2014, our effort again has increased substantially for juvenile and adult, as well as larvae. And then 2015 was the first year that we started to implement benthic sampling. So a grand total altogether from this level of efforts, about 2,300 samples looking for aquatic invasive species. Using this data, we can evaluate how thorough and how effective we've been at sampling the nearshore fish community, give us an idea of whether or not we're likely to encounter any new aquatic invasive species. So we use tools such as species accumulation curves. And this is a species accumulation curve using all of the samples that we've collected in 2015, and we estimate from that data that we've accounted for 96% of the potential fish species in the nearshore zone using 866 units of effort that we deployed last year. And so with this gives us a lot of confidence that we're putting a substantial amount of effort out there and increasing the likelihood of detecting new aquatic invasive species. As far as findings from this effort, there's been no new AIS collected in Lake Michigan or reported since 2011. However, there's been some new occurrences of previously established AIS since 2010. Based off of the USGS non-indigenous aquatic species database, there's 67 existing AIS listed in Lake Michigan proper and the tributaries leading to it. Again, provided the website link here. Of these species, only 2 of them, a crustacean, bloody red shrimp, and a mollusk, New Zealand mud snail, have expanded their range. For bloody red shrimp, again, pretty widely dispersed, located from Nobbin Way down to Chicago, back up to Harbor Springs, but in 2015, there was a new documented occurrence of it up in Beaver Island, Michigan. And then for New Zealand mud snail, again, it was located previously on reefs off of Waukegan, Illinois, but this year the new occurrences have been documented in the Pere Marquette River, actually just to the west of Baldwin. So that's all I have.